Today, we're going to talk about the most effective method for measuring shader performance. Let's go. So last week we talked about shader instruction counts, and I gave 3 main reasons why using the instruction count is not an accurate method for judging the performance of your shader. So last week's video was about what not to do, and this week I'm going to show you the most effective method for judging your shader's performance. So you're making a complex shader and you want to know if what you're doing is going to run fast enough or if it's going to slow down your game. How can you tell if your shader is too complicated? Or you have a really complex shader and you're trying to simplify it. How can you tell if your changes are making a difference? What you need to do is measure how long it takes the graphics card to render your shader. So, in order to do this measurement, we'll follow 3 steps. First, we'll build a very simple scene. Second, we'll run the scene on our target hardware. And third, we'll use a tool to measure how long it takes the scene to render. So first, let's start out by building a very simple scene. In Unreal, I'm going to come under File, and I'm going to pick New Level. Now I want my scene to be as basic as possible, so I'm going to pick Empty Level. And now I've got an empty level with absolutely nothing in it. The next thing that I want to do is add a plane to my level. So I'm going to come down here to my content drawer, and I'm just going to search for plane. And there I've got it, this asset called shape plane. I'm just going to drag and drop it into the level. And now I want to make sure that it's at location 000. So I'm just going to type all zeros here. And then in my viewport, I can hit the F key to focus on my plane again. I've moved it to the 000 location, so now it's at the origin. The next thing I need to do is add a light to my scene, and so I'm just going to click Create, Lights, Directional Light. And now I've got my directional light here. I'm also going to move it to the origin, but since it's a directional light, it doesn't really matter where it is in the scene. I'm just going to move it into the origin so it's a little bit easier to deal with. Now I'm going to hit E, and I'm going to rotate my light so that it's actually illuminating my plane. There we go. And then the last thing that I need to do is I need to add a camera to my scene. So I'm going to click on Create, and then I'll click on All Classes, and then I'll pick Camera. So there's a camera added to my scene now. And just like I did with the plane, I'm going to move the camera to 000, so it's in the center of the scene. And then I'm going to rotate the camera so that it's pointing down at my plane. I want to rotate it so that it's 90 degrees looking down at the plane. And you can see here in my preview window that my camera only sees the plane. If I move it over here, it's going off the edge of the plane, but I'm going to move it back to 0 so that the only thing visible in my scene is just that plane. My camera is staring straight down at my plane there. Now the next thing that I need to do is find the material that I want to measure the performance of and apply that to the plane. So I'm going to come here in my content drawer, and I'm going to find my materials folder. And in this case, I know that the material that I want to measure the performance of is called M Wood Oak. So I'm just going to click and drag that into the scene and drop it right on my plane. Now you can see that my camera view is looking at that rainy wood material. And now I'm ready to measure this material's performance. So I've created a really simple scene that just has a camera, a directional light, and a plane in it. And I've applied my material to the plane. Now, if you save this scene, you can use this scene over and over and over to measure the performance of various materials. And all you have to do when you want to measure a new one is just apply a new material to the plane. So once you have this scene created, you don't need to set this up again. You can just continually use this same really simple sample scene to measure your performance. All right, so the next thing that we need to do is we need to run this scene on our target hardware. And in order to do that, we need to build a package. And building packages is a little bit complicated in Unreal 5. Unfortunately, there's a couple of hoops that you need to jump through in order to get Unreal set up to correctly create packages. And I will put a link down in the description for how to do that. I'm not going to go over all of these steps because it's a little beyond the scope of this tutorial, but there are some extra things that you need to do in order to get packages building correctly. Beyond that, we're going to come up here to the Edit menu, and I'm going to pick Edit Project Settings, and then I'm going to pick Maps and Modes, and you need to make sure that the map that you created is here under Editor Startup Map, and also Game Default Map. Now, I haven't actually saved my map yet, so I'm going to come up here and do Save As. And you can see I already have one here called Material Speed Test. I'm going to call this one Material Speed Test 2 and hit Save. And now I'm going to make sure that that level is selected here under Editor Startup Map and also Game Default Map. There we go. And now I'm going to come up here under the Platforms button. And you can see that there's a bunch of different platforms I could potentially do a build for. But in this case, I'm just going to do my build on Windows just to keep things simple. So you can see I've got Windows here. Now, it's going to be best, whatever platform you're developing your project for, if you measure your performance on that specific platform. Because say I was developing a game for an Android device, if I were to measure the performance of my material on a Windows PC instead, the Windows PC results would have very little in common with the Android results. So I need to make sure that I'm building and running my project on my target hardware in order to get correct results from the shader time measurement. All right, so I'm going to come here under Windows, and I'm going to pick Shipping for my binary configuration. And what that'll mean is if I were to pick development, there would be extra debug options included in my package that would make it run slower. So if I want my package to run as fast as possible, I want to pick Shipping here. And then I'm going to pick Package Project. Now, if you come down here and under SDK Management, under Installed SDK, if this is blank, then you haven't set up Visual Studio correctly and the .NET SDK in order to be able to build your project. And so be sure that you follow the steps in the links I've included down in the description to make sure that you have your SDK installed the way that it needs to be. All right, so then you're going to pick Package Project, and Unreal is going to build the package for you, and you can place it in the location you want it to go. In my case, I'm just going to put it on the desktop, and I'm going to put it in this folder called Unreal, and I'll hit Select Folder, and it's going to build my package. All right, and my package is done. Now I'm going to go ahead and close down Unreal, and then I'm going to browse to the location where the package was created. And here it is in the desktop builds Unreal, and then there's this folder called Windows, because that's the target hardware that I created it on. And I have this executable called Material Speed Test. And so I'm going to go ahead and run that. All right, so here is my project running. Now you might be wondering, why did I choose to run this outside of the editor? Why couldn't I just take a look at the frame rate in the editor? And the reason for that is when your project is running in the editor has all kinds of additional features enabled to allow you to interactively edit your scene. And when you build the scene, it strips out all of that extra stuff, and what you have left is just your project, and it's able to run as fast as possible. If you run your project in the editor, it's going to be significantly slower, and you won't actually get an accurate measurement of how fast it can run. Now, in order to turn on a frame rate counter here, I'm just going to hold down the Windows key and press G. And you're not going to be able to see it because OBS doesn't capture it, but I'm going to be seeing on my desktop a frame rate counter under the little performance window, and it's going to show me exactly what frames per second I'm currently getting. And so what I can do now is go back into Unreal, edit this material, and package it up again and build it, and then compare the new frame rate with the previous frame rate. Now, it's always much more accurate if you can measure the milliseconds or the amount of time that it takes your scene to render instead of using frame rate. And it's a little bit more complicated, but I'm going to put a link down in the description that shows you how to add a frame rate counter right into your game project so that you can see that running in the game itself rather than needing to use some kind of external frame rate counter. And so that's the best way to do it. And now we're going to switch over to Unity, and I'm going to show you how to do the same thing. So from within Unity, we're going to pick File, New Scene, and again, I'm going to pick Empty Scene and click Create. We want an empty scene because we want a place where there's no distractions and nothing else to tax our GPU or our computer. We're just going to add a plane, a camera, and a light, and just keep our scene as simple as possible. So we're going to come down here to the project window, and I'm going to click on this All Models tab or selection here. And here's a model called a quad. So I'm just going to click and drag that into my scene. Then I'm going to select it and make sure that it's positioned at 0, 0, 0 in my world. And again, I can hit F to center my 0, 0, 0 location. All right, next I'm going to add a light source. So I can just come over here and pick light, directional light. And now I can rotate my directional light so that it's correctly illuminating my plane. And now I need to add a camera. So I can just right click here and pick camera. Again, I'm going to center the camera at 0, 0, 0. And then I'm going to raise it up just a little bit. And I'm going to rotate it so it's pointed straight down at my plane. And I'll just type 90 degrees so that I know that it's pointed directly at my plane. Then I'm going to raise it up just a little. And if I'm looking at my preview here, you can see that there's the edge of my plane right there. And so I'm going to lower it down just a little bit until my plane fills the entire screen. Okay, now I need to add a material to the plane. So I'm going to select the plane again. You can see that right now my material says no name. And so if I create a material, if I come down here to my materials general folder, I could create a new one just by right clicking here and picking create material. But I'm just going to use an existing one that I created. This one's called Material Performance Test. So I'm just going to click and drag and drop that onto my plane. You can see that I've got a little bit of a bump map going on. This is a shader graph that we created in a previous video. But you can put whatever material on here that you want to measure. The point is that whatever the material is, you can come up here under shader and pick the shader graph that you want to measure the performance of. All right, so if we take a look at our camera again, you can see in these preview windows that our plane is filling the entire screen. So we've got our plane, we've got our directional light, and we've got our camera. The next thing that we need to do is come up here under File and pick Build Settings. And we need to make sure that our target platform is set to Windows. Again, Unity supports a really broad spectrum of different platforms. Everything from the PlayStation to Android phones to iOS devices, all kinds of things. But we're just going to keep things simple and run this on Windows. Now, in order for my scene to be built, right now my scene is just called Untitled. So I need to do a File, Save As, and I'll put it in the Scenes folder. And again, here I have Material Performance Test Unity, and I'm just going to call this one Material Performance Test 2. So I'll go ahead and save that. And now in my build settings window, I can hit Add Open Scenes because my scene is open here. So when I hit this Add Open Scenes, it's going to add my Material Performance Test 2 to my list. Now I can check whatever levels or whatever scenes I want to be included in my build. And I'm just doing a build to test this one material, so I can uncheck everything except this one scene that I want to include. Then I'm going to hit Build down here at the bottom, and I'm going to pick my Unity folder to put it in. You can put it wherever you want on your computer, but in this case, I just have a folder on my desktop called Builds, and a folder inside of that called Unity. So I'm going to hit Select Folder, and now it's packaging up my build, and when it's done, we'll be able to run it. One thing that I want to point out is that I have this development build checked, and that's going to be really important here in a minute when I break out another tool that I'm going to show you. All right, let's switch to the folder where it built, and I'm going to close down the editor just so it's not running in the background. And then we're going to run our build here. So we have this Learning Shaders exe, and I'll run it. And you can see that we get a nice full screen version of our game. Now, if I check the frame rate on this, I'm noticing that my frame rate is 60, and it's actually locked to 60. And I don't want that because it's limiting what the actual performance is to 60 frames a second. Instead of me being able to measure what the actual frame rate is, it's putting an artificial limit at 60 frames a second. So we need to fix that. So I'll jump back into the editor. And so now that I'm back in the editor, what I can do is come over here under Edit, Project Settings, and I'm going to pick Quality. And you can see there's this setting called VSync Count, and it's set to every V blank. And what that means is it's going to limit the frame rate to the refresh rate of the monitor. And I want to remove that limit so that I can run the frames as fast as the video card can create them. So I'm going to drop this down, and I'm going to pick Don't Sync. And now, instead of being limited to the frame rate, it's going to just go ahead and create and render those frames as fast as it can. The other thing that you want to make sure that you do is you set your default quality to low. And what that's going to do, normally when you run your game, you want it to look as nice as it can, but in this case, we're just trying to measure how fast that particular shader or material will render. And we don't want all of the other things that the scene is doing, like rendering ambient occlusion and fog and volumetric effects, all those other things. And so by setting these settings to low, we get rid of as many other effects as we can. We try to move those out of the way. And there are even more things that you can do to turn off extra effects that I won't go over right now. But you want to try to turn off as many extra bells and whistles as you can so that the score that you're seeing is just the rendering of your material and not anything else. All right, so now that I've set those things, I'm going to go ahead and hit Build again. And I'll build this project, and we'll go ahead and run it again. And again, I'm going to hit Windows G to bring up my frame rate. And now that I've turned off VSync, I should get a more realistic or a more representative frame rate for how fast this is actually rendering. And it actually is rendering at an average of 120 frames a second now, 117. It's kind of fluctuating around a little bit, but I'm actually able to see the correct measurement for how fast it can go. All right, so using this method, I'm able to get a correct measurement for how fast my material renders. And now I can go in and make changes to it and see how those changes will actually affect my score. Now there is one more method that I want to show you that is the most accurate method of all, and it's using a piece of software called Pix. And Pix is some software that was developed by Microsoft, and it actually captures the commands that are being sent to your GPU and analyzes them and measures like things in exact speeds down to individual nanoseconds. So let's take a look at that next. All right, so this is the Pix software. And what you can do is launch your application from inside Pix and then do a capture of everything being sent to your graphics card and measure very precisely how long things take. Now, this works in both Unreal and Unity, as long as you measure with the development options turned on. I know previously I said that you should turn those things off, but you want to set the build to a developer build so that it has the debug commands and instructions built into it that Pix needs. Okay, so we're going to come here under the Select Target Process. I think by default this tab is set to Launch UWP, but we're going to come over here and pick Launch Win32. And in this case, I'm going to browse to my Unity build, and I'm going to pick the Learning Shaders project that we just created. So now that it knows what to run, I'm going to click Launch, and it's going to go ahead and run my build that I just created. Now, when it's running, you can see up here in the upper left, there are a couple of other additional options here. It says that my frame time is 10 milliseconds. And when you have this text up here, it means that your application is running from within Pix. So if I hit Alt-Tab and switch back over to Pix again, now I can hit this GPU capture button, and it's going to take just a minute and capture everything that it needs. Oh, you know what? There are a couple of things that I forgot to mention that you need to set in order for Pix to run correctly. The first thing is you need to come down here and search for Developer Settings. So I'm going to click on Developer Settings in Windows, and you need to turn on Developer Mode. In order for Pix to run correctly, you need Developer Mode to be turned on in Windows. And the other thing that you need to do is, if you're running an NVIDIA card, you need to open up your NVIDIA control panel here, just like this. And under the desktop menu, click Enable Developer Settings. And then once that's there, this developer new option will show up in this panel on the left. And you want to click on Manage GPU Performance Counters, and then make sure that Allow Access to the GPU Performance Counters is available to all users. Okay, so you need to turn on Developer Mode in Windows, and then allow access to the GPU Performance Counters to all users in the NVIDIA control panel. Those two changes will allow Pix to render correctly. If I didn't mention it before, I'm going to put a link down in the description to where you can download Pix, but this is a really powerful tool to analyze the performance of your software. So anyway, my sample program is running right now, and I hit the GPU capture button, and it created this capture of one frame of my program running. So if I click on this frame, now it's going to bring up the stats for the frame. And the first thing that I need to do is click right here to start the analysis collecting timing data. And when this happens, what it's going to do is it's going to close down the application that's running in the background, and it's going to go ahead and analyze the frame that it captured. So I'm going to hit yes to tell it to go ahead and do that. And it's going to do a bunch of calculations here and try to figure out exactly how long all of the different elements in that frame took to render. And so what I see here down at the bottom from left to right is all of the elements that happened on the GPU in order to render my frame. And there's a whole lot of stuff going on here, but if we want to find out exactly how long it took my actual material to render, what I need to do is look on this timeline for an element that's called gbuffer. Because the gbuffer is what gets written to when we're rendering the materials in the frame. And if I go under gbuffer and I find this draw indexed instance, that is the actual draw call where my material got rendered, the model that you can see here in the viewport. So if I look up here you can see under duration, this is measured in nanoseconds. So if we take that draw call, you can see that it took 794,848 nanoseconds to render my material. And so that is a very precise measurement of how long it took to render my material to the full screen. And if we want to convert this into milliseconds, we just move the decimal over 6 places, and it's just shy of 0.8 milliseconds to render my material to the screen. So this is a very precise measurement, and if I were to go and make changes now to my shader, I could run this process again and measure it again and get a very accurate count for if the changes that I made made my material more expensive or less expensive. Okay, so let's sum up what we learned today. So in order to get a correct, accurate measurement of how long it takes a shader or a material to render, you create a very simple scene with just a plane and a camera and a light, and then you build that scene and run it external to the engine. And then you can measure the rendering time either using a frame rate counter or using some really nice software like this called Pix. There's software on the PlayStation platform called Razer, or you can run Pix on Xbox. And I'm sure that there are equivalent options on the iOS and Mac platforms, as well as Android, for measuring precisely how long things can take to render. But this is the method that is most accurate, and you'll be able to measure like very small changes that you make in your materials. Anyway, so last week we talked about how instruction counts were inaccurate, and this week I showed you the accurate method for measuring the performance of your materials. I know that this is complicated, and if somebody could develop a faster, easier, more convenient way of doing this, I would absolutely love it. But when you need to know with precision how long it takes your materials to render, this is the way that you do it. Anyway, I hope this video was helpful, and I hope you enjoyed it. Be sure to come back next week, and we'll get back on track. We got a little sidetracked here talking about performance, but we're going to talk more specifically about some additional Shader Graph and Unreal Material Editor nodes. So until then, have a great week, everybody.